the beer.
You know, we should have done that. I think the next one, when we do traffic one-on-one, we need to have beers while we're doing the training.
Yeah. I'll defer to you on international beers that you've tasted and liked.
So what? I love my Belgian beers.
Okay.
So because I lived in the Netherlands for 3 years, and my wife's Dutch, so my father-in-law is like a beer enthusiast, and there's so many monasteries and things like that you can go to that it is absolutely awesome. So you go to these little monasteries where they've been brewing beer since like 1000.
Yes.
You know, and you're like, it's just like maybe sometimes the atmosphere. You know,
Because that adds to it.
Oh, totally.
I want to go to an Oktoberfest because my father's side was from Bavaria, southern part of Germany. And I always wanted, I just want that Stein, and I want that foam over the top, and I just want to.
Oh, you also want those ladies to bring it to you.
Well, that'll go along with it, yeah. With like the holding eight at a time. But
it is amazing.
I was disappointed in England. I went to England. Mm-hmm. I stayed diagonally across from Big Ben in there's a Marriott property right there,
brilliant.
County Court. And I said, I want to have a beer in an English pub. You know, I went to Trafalgar Square, and I couldn't find a pub. I went to Garfunkel's, had fish and chips. The fish was all bony. The beer was just, so I ended up eating at the hotel. It was very, very disappointing in England. So that was, chalk that off. But I came from Paris, and Paris food was awesome.
Yeah.
England, not as good.
Yeah, I would agree with that. But you got to go. You got to know the little gems to find in England.
Like anything else. Yeah.
I went there, and I was there with a bunch of friends, and
if the locals can show you.
We did a beer mile. So literally we walked a mile, but we stopped off at about 8 different pubs.
You did a beer crawl.
Yeah, literally. But it's literally called the beer mile because it's a mile long. And you walk all the way up and all the way back down kind of story. And then, you know, by the time it's 3 a.m. in the morning, you're jumping on the train to go back to the houses.
I did that in Nashville. I gave a talk at a conference down there. And I got over at 11, and I was with another engineer from VHB. And we said, we're going to go. Let's go to Jack Daniels. So we drove to Jack Daniels, took the tour, which was impressive.
It's beautiful.
Great tour. And it's a dry county. So they let you off in this beautiful bar, oak and everything. And they give you lemonade. I'm like, what's that? So then we went back to Nashville, and we did a Jack Daniels, same thing. Each bar, we had a straight Jack. Yeah. And it was awesome. And it was you're in Nashville, the country music, drinking Jack Daniels. It's like eating a hot dog at a ball game. You know, you need that.
Love it.
That adds to it.
Exactly. Yeah. So the first question I got for you is, what is your name and who do you work for right now?
Joe Herr. I work for VHB, Watertown, Mass.
Joe, you're the type of person that every single time I talk to you, I learn something new. This is why I was actually kind of like excited that I could actually ask you a bunch of questions about sort of a little bit about your career and also your enthusiasm. So, I mean, you're in traffic signals, but you're a traffic enthusiast. You've got equipment from way back when and all the rest. What made you get into traffic signals?
I got in by accident. I went to Northeastern University for EE, and they have a co-op program. So you'd go 5 years for your bachelor's degree. But that was I started in 73. And my co-op job, I had to get to public transportation because they didn't have a car and get out to the industrial belt around Boston. So I went to City Boston Traffic Department, and I did my whole 5-year co-op there with the city traffic. And then I stayed on there for 2.5 years after I graduated. And there was just something about that time. I mean, I liked electrical, and I liked the concept of traffic, and it was relatively easy to understand. And it was starting to go through a metamorphosis from electromechanical to electronic to microprocessor. And I felt like I was on a wave, a wave of transportation technology innovation. And it was fun to be on the ground floor on it. So I stayed in it. I enjoyed it.
And so you've worked with like electromechanical controllers to more modern type of controllers. Give us a little bit of the history of what actually, like, from what you first started with to where you are today?
The generations, when you start talking about traffic signal control, you start with NEMA. NEMA was the first national standard, came out in 1976. So before that, it was all manufacturer-specific equipment. Everyone did it differently. I mean, you can look at different books. It goes back to, I think, 1920. They say that's the first one, whether it was in Cleveland or whether it was in D.C. or somewhere else. There's always an argument. But around 1920s when it came out. And they mostly, well, the first one was just manual with the police officer with the switch at an intersection. And then it got into mechanical type, motors and camshafts and contact closures, green, yellow, red, green, yellow, red. No detection, vehicle detection early on. And then in the 30s, they started to do a little more sophisticated with electronics, a little bit, relays were there and they could actuate. They used like pressure plates, some basic, they had acoustic based on horn sounds. You can go back to the ITE books and see some of the old stuff. And then after World War II, with the technology that got derived from World War II, they started to get more advanced, radar, that was used for World War II. And even the electronics started to come in. You had, diodes and transistor logic. So you had discrete electronic components, but you still always had, the mechanical was sort of the meat and potatoes of the industry back then, with some electronic controllers that were used. And the timings were done with potentiometers on the front panel. That the timing was usually temperature dependent. Hot and cold, you get different settings on it. So they weren't exactly accurate to the 4 decimal points. So that was all the way up until 1976. You had this amalgam of different types of controllers. And then in 76, NEMA, National Electrical Manufacturers Association, came out with TS1. And TS1 was really the allowed on so many levels a commonality of product, a commonality of function, a commonality of environmental requirements. It defined, the biggest thing was the pinouts of the controller. It defined the 3 connectors, the ABC connector, 55 pin, 55 pin, 61 pin, what those pins were. So you can interchange it between manufacturers. You could take a Krauss-Heinz controller, interchange it with a Conlite, interchange it with an Eagle, with a Multisonics, all the different ones interchange. But also for traffic engineers, it defined what the functions were, what a minimum green was, what a yellow, what a red, what a max time was, what a recall was. So if you were doing a design and you called for a certain interval to be a certain value, you would have an assurance that what was put out in the street would match what was on your design. And before that, there was no commonality of function. Environmental requirements, it had to work within a temperature range, low to high, humidity, shock, vibration, electrical transient. So NEMA TS1 was really a benchmark for the industry in terms of traffic signal control. And again, that came out in 76.
And then how did it evolve from there? I mean, that was just the start of being the digital age of traffic controllers, really. And
Yep.
then, it's evolved from, being the electromechanical to then going to electronics to a certain degree. And now all of a sudden in, Linux-based controllers.
Yeah, it went through different iterations then. With TS1 in 76, again, I mentioned the ABC connector. It was basic traffic signal operation. So if you wanted to do coordination or preemption or anything external, you had these sub-assemblies that were put inside the cabinet, and they would manipulate the controller based on these external devices that went in there. So what happened in the late 70s and early 80s, as the 8-bit process, 16-bit process evolved, manufacturers could put all of that capability inside of the controller. So now you had coordination, you had preemption, enhanced detection, and so on inside of the controller. The problem is there was no D connector. There was no connector to get access to that defined by NEMA. So every manufacturer did it differently. So you had the D connector, which was non-interchangeable. The functionality of those enhanced operations were not defined. So every manufacturer did it differently. So what you had in 76, that interchangeability of product, interchangeability of controller, started to fizzle out through the 80s as more and more of those functions went inside the controller. And that was the big push for NEMA TS2 to come up with some sort of interchangeability. But at that same time, I'm only talking the NEMA world because that's what I'm the most the most familiar with. Caltrans in 1979 started with the 170 family of controllers. So they designed a cabinet where the software, the firmware, would not come with the controller. NEMA, you get the controller and you get the firmware. But the 170s, you had the hardware defined, but then the firmware could be developed by the agency. Caltrans did a lot of that, or you could have a third party put the firmware in the controller. So the 170 evolved into the 179. New York State DOT came up with an enhancement, then the 170E, and then the 90s went with the 2070. So you had actually two parallel forms of controllers in the US, the NEMA form and the controller form, and the Caltrans form.
Out of all those different eras, what was one of your favorites? I mean,
I'll be honest with you. When TS1 came out, I was floored. I mean, when I saw that controller by defined functionality, defined environmental, there was all of a sudden it wasn't the Wild West. It was a standard that benefited maintenance, it benefited designers, it benefited agency. It was just such a paradigm shift in what we had. That to me was a major step, and that
like
impressed
going
me.
from like a horse and carriage
to an internal combustion engine. That's what it was. Good parallel. Yeah, you went from a horse to an internal combustion engine. Now, granted, internal combustion engines today are better, but that one moment, that seminal moment, was eye-opening, and I'll always remember that.
How quickly did the industry actually change? You know, like I think about horse and carriage, and it took like almost 10 years, and almost all the horses and carriages were gone in a 10-year period. How long did it actually take to change? You know, when TS1 came out, you know, did agencies just jump on it, or was it quite a slow process?
For TS1, they jumped on it. They jumped on it because manufacturers were putting that out as a product. I'm not sure if the pre-NEMA offerings were still there for manufacturers. So they jumped on it pretty readily. It didn't happen with TS2. TS2 came out in 1992. It came out with two versions, TS2 Type 1 and TS2 Type 2. TS2 Type 2 retained the A, B, and C connector of TS1, but they used, I think, 24, 26 pins. You could conditionally have them be either coordination, preemption, and so on, but you still had the ABC connector. It was downward compatible with TS1 cabinets. It had a lot of pluses. TS2 Type 1 got rid of the 171 wires, one wire, one function, and they went to the SDLC communication, the high-speed communication between the internal cabinets. You didn't have the downward compatibility, but you did have a forward-thinking controller platform that can be used into the future. And most places went with the TS2 Type 1. But it came out in 92. A lot of agencies didn't embrace it for 5, 6, 7 years because TS1 was so powerful and they had a lot of stock on it, and you didn't have that downward changeability. So that took a lot longer than going from TS1 for at least agencies that I knew. TS2, it took a lot longer because you had a lot of existing stock out there.
And now everything's moved over to ATC. Not everything, but I'm just saying the latest is now the ATC standard.
Yeah.
And I see certain agencies looking at it going, yeah, we're going to do it. And other agencies like, no, we're staying with the NEMA standard. What's your point of view on that?
ATC really started in 1999. It was NEMA, AASHTO, and ITE. It was a consortium of those three because after TS2, they came out with NTCIP, the communication protocol, and that evolved in the mid-90s to develop that. And now the ATC standards development was very similar to that in the way it was set up. Had public and private entities in there, manufacturers all contributing to this process. Started in 1999, it included the ATC controller, the ATC cabinet, and the ATC API, Application Program Interface standard. And that started in 99, and it took a while before that standard actually got developed because of funding and other challenges, limitations that came on that. The cabinet, the ATC cabinet came out, it was the ITS cabinet in 2005, 2006, and they deployed that down in Harris County, Texas. So that went out in the street in 2000, I think it was 2006. It really didn't get embraced by the rest of the country. A couple of manufacturers did have it. And I think there was funding issues with the committee, so it was on pause for a while. They started back up 2011, 2012. They changed the name of the standard that was being developed on from ATC cabinet from ITS cabinet to ATC cabinet. And it didn't come out as a full standard approved nationally, I believe, until 2019. And that was the ATC. But the ATC cabinet is very similar in architecture to the TS2 Type 1. It has an SDLC bus, but it's faster. It does functionally more. The load switches are now switch packs. It does more output channels, more input channels. It's NFPA 70E, so there's a safety component in it. It monitors current, which TS2 did not have. And I think another driving force is all the applications that were coming out between flashing yellow arrow, leading pedestrian interval, bike signals, and so on. The demand for the application at an intersection was becoming more and more than the 16 channels available under TS2. So you were constricted under TS2 Type 1 with the MMU. And this one now has 32 outputs, and they can monitor all 32. And they have 120 inputs, which again is good because detection inputs is not just for phase calls at an intersection. Now you have dilemma zone, you have adaptive system control, and you got signal performance measures, all having their unique requirements for detection. So have the ability to have
bicycles
120
and all those kind of things.
That challenges for input that gets absorbed by this new cabinet as well. So and again, you think about it, the standard that we had before that came out in 1992. It's now 2025. Not too much technology to survive that long.
Yeah. So here's a question for you. When you're driving in your car and you're driving along and you're driving towards a traffic signal and you notice something that's not quite working the way you think it should, what frustrates you the most when you're driving through some city, a city that you haven't worked on?
First off, I feel bad for the agency for funding because I can't do everything. I feel bad for the maintenance person who has to go out there and maintain it. The traffic engineer who has to do permitting, has to do signs, has to do parking meters. So I have a great sympathy for people to be able to maintain it. I mean, it's not like, an amusement park that has, so much money per square foot to maintain it. They don't have that at a local level. But from a purely operational point of view, it's inefficiency of detection when it's not running as efficiently as it could be, whether it's too long of a green time on a side street or too long on a main street or along those, or if it's a coordinated system, you're not getting progression in either direction when it's running coordinated. That would frustrate me a little bit.
You feel like each time you drive through there, you're like, I know exactly what to do to fix this.
No, I'm not going to say that I know. I know what the problem is. I'm not sure what it could be a lot of software, hardware. It could be a lot of elements that would cause that not to work. Clock drift, what have you,
maintenance. You said maintenance, and I mean that's one of those things that I notice the most. It's like you can put in the most fancy system in the world, but if you don't maintain it correctly, it ain't gonna work really well.
Yeah, it's like anything else. If you don't change oil in your car, it's gonna die. You have to maintain a system. It has to be maintained when you put it in. There needs to be resources, and I think as technology's evolved, we're able to quantify how well the system's performing. If all of a sudden if something's not working, and it can be an automated process rather than a human going out there and doing it, it becomes easy to get access to that information. So when you do fix it, you can sort of quantify return on investment. Hey, I invested this much in my operations and maintenance, and this is what I'm getting in return. And I think that's going to help us as we move forward to have that data available.
And like measures of effectiveness.
Yeah, measures of effectiveness. But it's still data. Someone needs to take that data and turn that into usable information, usable metrics that can be quantified.
If you had unlimited resources, an agency with unlimited resources, unlimited time, unlimited budget, how would you go about solving the traffic problems? in traffic signals?
Yeah, traffic and transportation, especially in a city, is a multi-layered, the areas. I mean, I'm in a very, very narrow little part of transportation and traffic, focusing on operations of signals. I think a key part is training. I think training helps, but just to get staff who can do that, it just takes such a long time to ramp staff up to a level where they can help an agency operate and maintain. It really, there's no one course. I mean, you have to know design. It's like saying, how can I get someone to fix my computer when they don't know what you're supposed to get out of it? So you need to know the application side as well as the technology side. It's a fallacy to think, hey, I can take a technical person out who has a technical degree and all of a sudden have them work on signals when they don't know maybe what coordination is, what preemption is, how it's supposed to be used, how it works. And at the same time, you can have a designer who gets involved, and if they don't know the technology part, there's that gap, and that's the challenge, is filling that gap. And I think additional finding the staff, number one, which is a challenge in and of itself, but secondly, additional training to be able to help them on that.
It's a good point, because I think everybody focuses too much on technology and doesn't focus enough on the training side of it.
Yeah.
You can put in the best system in the world, but if the people don't know how to operate that system, it's not going to help.
No.
It's like, which traffic controller is better? They're all good if you know how to program them, because they can all do all those kinds of features.
Yeah.
And I think that's kind of I agree with you. I think training is so important, and people need to spend more time on training.
Yeah. And the other challenging part is technology is moving faster than standards can keep up with it, because it just keeps evolving and changing, and then it can't just be a one-time training. It needs to be an evolving training that keeps up with what is available. What tool do I have to solve X problem? That's what it gets down to. I have a problem. Define the requirements. Engineering 101. What do I need to do? What are the tools in my toolbox that I can use to mitigate that, to work on that? And that is sometimes projects fails and systems fails because you're using a square peg in a round hole. You don't have the right fit.
How do you get, because one of the things I like to do at training is not teach someone everything in one go. Because if you try to do that all in one go, they're only going to remember a certain amount. And I'm a real big fan of doing a training session every 2 weeks or every 4 weeks, and doing little bite sizes. How do you do more of that with agencies? Because it's easy to do, to get everybody to take a day off and you do a whole day of cabinet training, but the person's only going to remember 10% of what you teach them. You almost need to break these things up into these smaller sessions.
I agree. You do need it. It needs to be in a digestible form. And trying to do it all at once. You take an ATC cabinet, do 8 hours on it. There's just not enough mud's going to stick with them, because you're throwing so much at it. It's going to be overload, and you're not going to figure it out. My thing is, take a little bite at a time. Understand what that component does, not the whole picture. What does that do? And I have a presentation like in PED buttons. What does a PED button do? There's so much involved in pedestrian buttons. Take the small one. And then the other thing is understand what it's, if you've been in the industry, what is its equivalent in the previous generation? What did that do? And what does the new one do differently? So you already have a base of information to go by, and all you're doing is adding to the information you already have. But if you're starting out new, then it becomes more of a challenge, because you're starting from base level, and now you got to work your way up on it. But having it digestible in small amounts over time, it's like mixing a cake. You don't throw all the ingredients. You put it little by little to mix it up. You put them all together, you're just not going to get what you want for an end result.
I got a cool question for you, and maybe you can help explain this. The movie The Italian Job.
Yeah.
Everyone talks about how, and I don't know if you've seen the movie where you got a hacker that comes in and he makes 2 traffic signals go green at the same time. Can you explain why that can never happen in the United States?
Yeah, I'd have to look to see what's under the hood with the cabinets that are there, but there's a conflict monitor, depending on the age. TS1 was conflict monitor, TS2 was MMU, and ATC is cabinet monitor unit. And they have compatibility channels in there that said if these two channels are on together, that's a failure. The signal goes on flash. And those are hard-coded, hardwired into that device to make sure that if you did have a green on one approach and a green on another, the signal would go at flash. And it would, that just wouldn't be allowed. So that's like the primary piece of equipment in the cabinet. The controller runs it, but the monitor unit is the one that will take a look at it and make sure that it doesn't fail.
And explain how the monitor has to be from a different provider than the traffic controller itself. In other words, it's a total separate box. It's not provided by the same manufacturer. It's a total separate system. And some of the the old school style, it was literally cut into the board in the monitor that you couldn't physically have this screen and this screen at the same time.
It is it's its own separate device in the cabinet. Is the monitor. It is separate from the controller. It's separate from the communications, separate from the detection, separate from the controls and such. But yeah, it is a separate device.
So it can't happen.
No, I have never run across. It is. I've never designed a monitor. I can only go by my experience, and it just. Yeah, monitors are designed not to have that happen.
Over your course of your career, you've worked on many, many, many projects. What are some of the exciting projects you've worked on?
That one I'm going to draw a blank on.
Or what are some of the largest projects you've worked on?
I've worked on, probably the newer ones, worked on the new connected vehicle technology, which is pretty exciting. In general terms, it's a technology. It's looking at connected vehicle technology and the opportunity it has for the future. Where it's not just a green, yellow, red light, but now we can have interaction between the vehicle in the roadside, the potential for vehicles to vehicle, the information that's provided with connected vehicle. And the biggest opportunity is safety. I mean, that's what it's all about. It's safety. That's what we do in our profession, is make it safe. That's the prime directive, is to make it safe for the users in the roadway. And I think connected vehicle technology, by sharing information about what's happening ahead of time, to understand if there's any cautionary, any conditions that potentially could cause a problem that the driver can know about in advance. That if that saves one life, it's worth it. That's what you strive for, is to make it safe. That is the prime thing. When you put two greens up so that one vehicle doesn't occupy the same space and time. That's what traffic signals are all about. That's 101. You try to prevent people from having a 90-degree collision. You try to prevent a pedestrian walking across the street when there's a vehicle that's going to make the safe movement. I mean, that's what it's about. So the more that you can have technology, it's not just about mobility. It's not about those type of applications. It's all about safety. So for me, the most exciting time is that I've been in my career long enough that I've been here to see the start of the connected vehicle emergence, and maybe potentially autonomous vehicle, emergence from when I started, when it was getting back to motors and gears. That's been probably I would put that outside of all the myriad of different types of cool projects from a hobby type point of view, from a point of view as an engineering challenge to work on. The one that I would point to is just the emergence of connected vehicle and what it allows for the future. That would be me.
You talked about safety. I mean, obviously you've worked your whole career in traffic and probably created countless better, safer intersections. Is that when you're telling somebody about what you do and how you provide safer traffic for people, I mean, is that a rewarding thing that you go home and you go, you know what, actually, I've created so many more safer intersections over my career that, I've actually helped society.
Yeah, definitely. Yeah, the ability to have a positive impact on people that I'll never meet it's a cool feeling. It's a great feeling to do that, and to have the immediacy of it as well. Especially if you're out and there's designs, you got to develop plans and specifications as a planning component. But we're actually out there in the cabinet, and you can mitigate a condition, or you can make it safer through whatever operational switches and knobs you flip to be able to do that. Or you make it easier for a fire truck, emergency vehicle, or an ambulance to make a response, or whatever that case may be. If you can do something positive, that's a very rewarding part of the job. I mean, like I said, I know so many people that you do design and you just don't see what happens, what the end result is. But in this industry, you can have such an immediate effect and a positive effect. It does make you feel good. It's a rewarding part of the job.
So let's say there's a young engineer that's just finished university or technical college, and he's going, hey, what am I going to do? Well, how would you, promote, talk about the traffic industry on somebody from that side? Why should they join?
I would say first, find out about a little bit more, because it's gonna change. If you're into, first thing, helping people, make an impact, solving problems. I mean, that's why you get into engineering, is solving problems, whether using chemical or mechanical means or whatever. You're a problem solver, that's number one, but helping people at the same time. You get into biomedical, that's great. You're understanding stuff, it's a direct correlation, it's medical, you can do so much with your work to do that. And this is in a similar vein in terms of having a positive impact on society. Think of what you can do in terms of reducing the number of accidents, coming up with technology that will take what we have now in terms of number of accidents and fatalities per year, and try to minimize that through the better use of technology. And if you can do that to save one person's life, that's immeasurable.
And I think it can be a huge amount, because there are 43,000 people in the United States that are killed every single year on the roads. And you kind of go and you think to it and you're like, you know what? If you implement something that's smart, clever, emergency vehicle preemption, those kinds of things, it's so directly related to saving lives that I think actually at the end of the day, you can go home and you can say, you know what? Yes, you're getting a paycheck for what you're doing, but actually society on its whole is really benefiting from what you do.
Yeah, and you have to do it, and you have to do it well. You have to understand what's available to you, and you have to have a proper application of that at the same time. And for young people coming out of school, I think you're going to have a wide palette of choices for what you want to get into. Just take a look at that and look under the hood. It's not just green, yellow, red like it did 120 years ago. That technology is going to change. At some point, we're not going to have traffic lights. You don't need them. They're only for humans to see. It's not machines. Don't need them. And the ability to be able to create a system where you don't have two vehicles occupying the same piece of asphalt, or you don't have a pedestrian or a bicyclist or a school bus, have that. I mean, the opportunity to use technology to make it safer is, I think, would be a great carrot for someone to investigate and look into that type, because it is very rewarding.
How do they go about it? You went and you worked for the city of Boston while you were doing your university degree. What's the best way of somebody, they're studying right now and they're like, hey, I really like this idea of doing traffic. Like, what's the best? Should they go look at like the city or a DOT? Are there any sort of ways of
Yeah,
getting
I mean,
in?
DOTs even, a lot of DOTs are working. There's intern programs out there. There's co-op programs out there. There's a lot of different ways that can be exposed to it. Again, Northeastern has its co-op program to be able to try different types of jobs and career opportunities that are out there. So there is a lot.
Now, you're a generational family within traffic. Your son is in traffic. How did that come to be?
He was he was working for a firm, and he'd worked at it for 12 years. He's a mechanical engineer, minor in double E, and we needed someone at VHB. And he had interned there when he went to college, although it was more for survey and such. But we just saw an opportunity to look for someone who could fill that void in technology. And he has a passion for technology and all of the communications and networking, computers. He had a passion for it. So I said, Joey, this is a good time if you want to consider coming over. I mean, VHB's a phenomenal company, and have an ability to come in. And they knew him. He had name recognition with mine because he has the same name. And I said, just try it, because he did do HVAC for a long time, and he liked that. And I give him a lot of credit coming from doing that for 12 years and being very efficient in that industry, and all of a sudden, doing not quite 180 degrees, but certainly a different field, and pick it up. And he's over here now, and he doesn't work as much on the traffic engineering side. He's really on the technology side and doing the technology side. He's embraced it, and he's doing really well. So I'm really happy for him and proud of him.
It must be so cool being able to, impart some of the knowledge that you've collected over all of these years to him, and then kind of see him sort of grow in that role.
No, the knowledge, it's the other way. I'm honest to God, I'm learning from him. He picks things up and is able to connect dots on technology. I can only dream of how he does that. He's very good at it, and it's good for VHB because we needed someone with that type of background. But yeah, he doesn't work too much on the application side of traffic signals like I did. So it's cousins in fields, but he's not really doing what I do, although we work in the same group. He handles, not that he's siloed either, but he works in a tangential part of what I do, and I work in a tangential part of his. But it takes a village because we need all of these different skill sets, and we have a lot of different skill sets within our group to be able to work on comm, networking, planning, design, and so on. You need all of that capability under one roof to be able to make sure that it's planned properly, it's constructed properly, and it works as designed at the end of the day.
This is one of the things I've noticed working with VHB is obviously all the planning happens, but past the planning, it goes down to the real implementation and the real actually all right, now we've put it into the field. Is it actually working correctly? Yeah. And then going in and making those changes and all the rest. It's not like hey, we've done a design, here you go deploy. You guys actually get your hands dirty, and I mean, yourself, you're one of those people that really actually gets your hands dirty and says, well, what we designed didn't quite work in the way that we thought it was going to work. Let's go make these little changes, and then all of a sudden, it works the way that it was intended.
Yeah, there are field conditions that might change from design. I mean, I'm not going to say it's more of an art than a science, but there are things that aren't going to come out in numbers when you actually go out there when something gets implemented. So there's always a fine-tuning. I mean, there's modeling software out there and there's statistical stuff, but there's a lot of times conditions in the field are going to change, and you have to be nimble enough and know enough about what you have available to you within the technology to make that adjustment. And again, it gets back to what I mentioned before. We're getting a lot of data in now, so it takes that that man-hour effort to be out there and observe things for a long period of time. Now you have data available to you that can at least give you an insight into what may be that that you could bring technology to bear to mitigate a problem.
Talk about how ITE, IMSA, ITS America, those kind of organizations are important for someone new in the industry, the learning, the knowledge, and so on.
It is, aside from the technical knowledge, I mean, the papers and the publications and the research that all three of those organizations are heavily involved in, it also gives you an opportunity to meet fellow practitioners across the country and learn from what they have experienced. I mean, that is invaluable because a lot of this is not written or researched because things are coming out so fast to see what works and what doesn't work. What are the lessons learned from some of the things? What are the new trends, across a whole myriad of subjects? And I think involvement in those professional organizations is very important to not only for your own technical knowledge, but also for developing relationships that you can call on those folks when something comes up and say, hey, if you run into this, how have you addressed that? And those organizations are the pool of talent across the country of those type of practitioners that you can reach out to.
And you've worked on projects all across the country. I know you travel all across and you look at different things. Who's some of the sort of people that you ended up sort of calling on, for advice in your early days that sort of gave you that kind of knowledge? Because now everybody calls on you, and asks for your information. Who's some of the mentors that you had?
I think when I started out, it was all local. I mean, it was in Massachusetts, and then you join the sections, and it's people in New England that you end up doing. And as you get older, it becomes national, but it's also academia as well to find out what's on the drawing board. What are they looking at? What is their research showing? So as you start getting older and you have an outreach with people, you get to meet those type of people. And that's been key to me is making connections with people at the college and university level to be able to understand what they're thinking of and what their data shows and how they want to implement specific operations out there that would again make things safer. So that's those who I reach out to, and also manufacturers. I mean, it's not just colleagues that you're working on, but understand what the manufacturers are thinking, because they're listening as well. They're listening to their clients, and they have a wider field to be able to pick for nationally. I mean, they're in all 50 states, and some of them internationally. So they have their fingers on the pulse, and if someone's writing a spec in a state in the West Coast, I'm interested in why that's in there and how can I apply that. And a lot of that becomes part of that research that we do to keep our ear to the ground, because things change so much. So, yeah, having manufacturer input is pretty important as well.
So one day you're going to be sitting on the beach in Aruba, relaxing, taking it easy. What is something that you're going to miss from the industry?
Probably two things come to mind. Number one, what I'm going to miss is making a difference, helping make a difference from a safety point of view. I'm not going to deny it. To go out there and make things, see a problem, see a potential problem, flagging it and seeing how it can be mitigated. That, and solving problems with that. And solving problems, making these safer, they're sort of one and the same. But the thing I'm going to miss the most is the people, interacting with the people. It's a phenomenal industry with some incredibly talented people that I've had the pleasure of meeting and working with over the years. I'm going to miss that. It's almost like extended family working in this industry. It's a very small industry. You go to a national conference and you talk to someone, and 6 degrees of separation. It's probably like 3 degrees of separation because you're going to know people there. And once you develop that commonality, you're not competitors. It's everyone's trying to do the same thing, and you can't win them all. So there's a camaraderie that goes along with it. It's like this conference right now. I mean, a lot of other designers and consultants here, but I have tremendous respect for all of them, and they're all just the same type of person. And I'm going to miss those stories and talking to them about their experience. Yeah, we compete on projects, but you can't win them all. And if you're going with that attitude that, hey, we're all, all oars are in the same direction, trying to make things better. I mean, I'm going to miss that as well. So those are the two things.
In 5 years, 10 years down the line, when people talk about Joe Herr, what do you hope they say about you?
First, they're going to be talking about my son, because he's going to overshadow me by a long shot. Jeez, that's like, what do you want on your gravestone question? I don't know. That he tried to do a good job. That's he tried to help people out.
I mean, the knowledge. I mean, I talk about people, and I'm like, every single time I speak to you, I learn something new. So like, my view on it is, I think people are going to talk about how you increased their knowledge, made them understand traffic more, actually understand how traffic really works from first principles. Because that's kind of what I learned from you, was more of the like, oh, I didn't quite understand that concept. And then the way you educated, the way you explain it from first principles is really, really like, I think it's because you understood traffic from the base level, from electromechanical all the way up to where it is now, that you understood all the concepts. And I think you've educated so many different people in this industry.
Thank you. But I'm also fortunate that I've been able to stay on the technical side. And I've been blessed to do that. They allow me to be an engineer. You just stay as an engineer. And to be at that level for such a long period of time, I'm very fortunate to have that. If I didn't have that, I wouldn't have the knowledge I have today. So I'm grateful for people who allowed me to, probably because I tried other things and I was bad at it. So they said, get back to where you were. But I'm blessed to have that. And I also like sharing information with young people, whoever, to help them along. Because I had that type of mentoring growing up by people within VHB, within my firm, helping along. So that's what you do, is you're all part of the same team, helping them out. So hopefully I helped some people as they were in their careers advancing, share information. Again, I don't know all the answers, but I know a lot of people who are really smart that I can call on and share that information. So if I can make connections and say, hey, I don't know, but this person can help you out. This is his email address. This is their number. Yeah, I'm all about that.
And I know you love Aruba. Where else are you wanting to go? What you've obviously got some plans and things like that.
I'd like to go back over to Europe again. Go over to Italy and Greece, and I'd like to go to Germany, Switzerland. I've flown in and out of Switzerland, but I've never been to Switzerland. But yeah, that's the one thing. When I retire, I want to travel more. Take the time to travel. When you're working full time, you only get so much vacation time. So to be able to take that time and be able to see other places and, look at history. I mean, to be able to, I've seen a lot in the U.S. for history, fortunately, and I'd like to go over to Europe and maybe, see some of the countries that I haven't seen. So that's on my scorecard, my schedule for when I retire.
Any other final words you want to give?
No, hopefully people learn something from this. Like I said, you probably could have got a few dozen other people to sit here in the same chair and give their comment. But I appreciate being asked about it, and if it'll help with someone down the road, that's great. I'm happy to share my experience and what I've run across, and a little bit of the technological ladder that we've climbed on traffic signals. And I wish you best with the interview and how you use it.
Yeah, and we're going to obviously go through tomorrow. We're going to do some traffic 101. So I'm looking forward to that. So anyone that watches this, they can see Joe Herr do traffic 101 and actually learn from the basics like I did to actually understand how traffic really works. So
Sure, happy to do it.
awesome. Thanks, Joe.
Thank you.